Before watching the video, do subscribe my channel and hit the bell notification icon to get the instant update. The major application of this chapter is to balance the redox reaction. There are many redox reactions which are highly complex and we can't balance them by trial error method. If I have a simple reaction of Na reacting with HCl, it will form NaCl with half of H2. It's a redox reaction because sodium here is changing from 0 to +1 and hydrogen here is changing from. So sodium is clearly undergoing and hydrogen is undergoing. It's a redox reaction and this redox reaction I can balance by trial error. मतलब directly balance हो जाएगा. Na with twice of HCl gives 2 NaCl with half of H2, not half, ये एक ही हो जाएगा. मतलब अब ये balance हो गया बराबर. मतलब this type of reaction we can balance it very easily. But there are many redox reactions which are highly complex and they can't be balanced by trial error method. So we have some rules to be followed to balance the redox reaction with the help of oxidation number. And there are two ways in which we can balance. First is oxidation number method and second one is called ion electron method. Now what is ion electron method वो second part में discuss करेंगे. अभी first part को हम discuss कर रहे हैं which is oxidation number method. So you can see the question 17 how the question could be asked. Balance the redox reaction by oxidation number method. Oxidation number method. So I'll explain step by step, just follow the step. एक example खाली ध्यान से observe करो, बाकी सब आप वही method से करोगे. Just observe it carefully. Stop writing and pay attention. The question is, balance the following equation for the redox reaction in acidic medium. Now this is something very important. A rule में इसका एक condition आएगा. In acidic medium by oxidation number method. And the first example, in fact एक ही है, MnO4 minus plus SO3 minus 2 या 2 minus gives you Mn with a 2 plus and SO4 2 minus. If I just talk about the name of the species just for understanding, MnO4 minus is it's manganate. It's KMnO4 ka anion and KMnO4 you should know it's potassium permanganate. So this is permanganate anion. SO3 minus 2. अगर किसी आयन का नाम देखना है ना, H अटैच कर दो. So this is H कितना अटैच करोगे, that will be equal to the charge on the anion. So the corresponding acid would be H2SO3 and which is famously sulfurous acid. So this is sulfite. Then Mn2 plus, it's just manganous similar to ferrous. Manganous similar to ferrous and this will be sulfate obviously. Clear? So it's permanganate reacting with the sulfite giving you manganese and sulfate, just for the understanding. To balance this reaction, the steps to be followed. Step 1. Identify the oxidation number of all the atoms in the given redox reaction. All the atoms. So in case of MnO4 minus, I know the oxidation number of oxygen as -2. So I'll calculate x minus 8 equal to -1. So x comes out to be +7. Now those big calculation you don't have to show here, direct करना है. Sulfate के केस में oxygen is known as -2. So x minus 6 equals to -2. X would have +4. Mn2 plus single atom का charge itself is the oxidation number, so +2. And in sulfate oxygen is -2, x minus 8 equal to -2, sulfur will be +6. Hopefully first step is clear. ठीक है. Step 2. Identify the species undergoing oxidation and the species undergoing reduction. So here plus 7 manganese is changing to plus 2, which is a decrease in the oxidation number, hence it's undergoing reduction. And S from plus 4 is changing to plus 6, which is increase, so it is oxidation. So we have observed that manganese undergoes reduction and sulfur undergoes oxidation. Correct? Now step number 3. I am not writing the statements over here, main steps की बात कर रहा हूँ, ध्यान देना. In step 3 you have to observe how much is the increase and how much is the decrease. So manganese, I can say it's changing from plus 7 to plus 2. So the decrease or increase? Decrease. So the decrease in oxidation number is minus 5. When you show a decrease, it has to be with a negative sign. The signs are very important in redox, क्योंकि वो सारा charge के ऊपर related है. So decrease in the oxidation number is minus 5. Clear? And this decrease in oxidation number is actually written per atom. Per atom. एक atom का decrease हो रहा है कितना? minus 5. अब मान लो यहाँ पर मैंगनीज के 2 या 3 एटम्स होते हैं, तो एक एटम के लिए अगर minus 5 है तो 2 के लिए minus 10 होता, 3 के लिए minus 15 होता, एंड सो ऑन. पर यहाँ पर मैंगनीज का सिंगल एटम इन्वॉल्व है, सो पर एटम का जो डिक्रीज है वही टोटल डिक्रीज भी लिखा जाएगा. आई एम जस्ट राइटिंग स्पेसिफिकली बिकॉज आगे जाकर मल्टीपल एटम्स का भी कॉन्सेप्ट आएगा. ठीक है, तो स्टेप्स जो फॉलो करना है, इसमें पहले डिक्रीज ऑब्जर्व किया एंड द टोटल डिक्रीज इज minus 5. सेम वे में सल्फर इज चेंजिंग फ्रॉम इन द ब्रैकेट plus 4 to plus 6, so it is increase, hence we will say therefore increase in oxidation number per atom is plus 2, and that's why we only write the oxidation number which is for a single atom. ये रीजन था. एक एटम के लिए पहले लिखते हैं, फिर अगर मल्टीपल रहेगा तो मल्टीप्लाई बाय व्हाटएवर नंबर ऑफ एटम्स वी हैव. ठीक है, सो यहां पर भी एक ही एटम है, तो टोटल इंक्रीज वुड बी इक्वल टू प्लस 2. दिस इज व्हाट इज इंपॉर्टेंट इन द स्टेप नंबर 3. Correct? Now any redox reaction would be balanced, would be said to be balanced if the total increase is equal to the total decrease. अब जितना इंक्रीज हो रहा है और जितना डिक्रीज हो रहा है, अगर वो बैलेंस हो जाएगा, then the redox will be said to be balanced. So balancing by oxidation number method is simply balancing the total increase with the total decrease. Now if the increase is 2 and the decrease is minus 5,
minus 10,
then to balance off, I have to multiply this decrease by 2 and the increase by 5, so that the decrease would become minus 10, which will be balanced by increase of plus 10, and the reaction would be said to be balanced. समझा? Is this clear? अब जो मैंने बोला है वो मल्टीप्लाई करोगे कहाँ? When I say multiply this by 2, मतलब multiply the manganese species by 2. So 2 stoichiometric coefficient here and 2 here. They are called stoichiometric coefficient. Hopefully you remember the name. Stoichiometric coefficient. And when I say multiply this by 5, so multiply sulfur species by 5 here and 5 here. Clear? So next step, step number 4 is balance. What we have balanced? Total increase with total decrease. So the conclusion is multiply Mn species by 2 and sulfur species by 5. So after this, rewrite the equation now. The equation would be now twice of MnO4 minus plus 5 times SO3 minus 2, giving you twice of Mn plus 2 and 5 times SO4 2 minus. Yeah. Up till step number 4, only the species which have undergone the change will get balanced. If you see, 2Mn is balanced with 2Mn, 5 sulfur is balanced with 5 sulfur. Now next steps में you have to balance the oxygen atoms. तो step number 4 तक कौन से species balance होंगे? सिर्फ Mn और S. ठीक है? अब moving to the next step, step number 5. Step 5 is specifically balancing of oxygen atom, and the rule is you find the total oxygen on the left and total oxygen on the right, and wherever there is deficiency of oxygen, you add the water molecules. Matlab, on the left, how many oxygen do you see? 8 plus 15, which is 23 on the left. On the right, 20. So कमी कहाँ पर है ऑक्सीजन की? राइट में. कितने कम है? तो 3 H2O ऐड कर दो. The rule is wherever the number of oxygen are deficient, add that many oxygen in the form of water molecules. मतलब यहाँ पर 23 है और यहाँ पे 20 है. The lesser number of oxygen on the right will be balanced by adding those many H2O molecules. Meaning now I will rewrite this as twice MnO4 minus plus 5SO3 2 minus, giving you Mn2 plus 5 and 2 and 5SO4 2 minus, and then plus thrice of H2O. Whatever new step you introduce, just highlight it so that you understand what have you done. Clear? Then if you add the water molecule, the hydrogen becomes imbalanced. So step 6 is to balance the hydrogen atom. Now the rule is this reaction is carried out in acidic medium. So the hydrogen should be balanced with the help of H plus ions. Again rule वही है, जितने H plus या जितने hydrogen deficient है, you have to balance with the H plus ions. On the left, how many H do you see? Nothing. So 0. On the right, 6 hydrogen. So this 6H would be balanced with the 6H plus on the left. Meaning, rewrite the equation twice of MnO4 minus plus 5SO3 2 minus plus 6H plus. This is the new part. And then balanced as Mn2 plus plus 5 times SO4 2 minus and thrice of H2O. Clear? Now this is the balanced redox reaction, and redox में balancing करने का एक self verification method है. First of all, if you observe the oxygen and hydrogen, all the elements along with manganese and sulfur should be balanced. Mn and sulfur was already verified. Now look at the oxygen. It's 8 plus 15, which is 23. This will be 20 and 3, 23, and 6H balanced. But the redox is said to be balanced only if the atoms and the charges are balanced on both the sides. So next step verification बहुत important है. अब ध्यान देना please. Total charge की अगर मैं बात करूँ तो twice of MnO4 minus has a charge of गलत -2. 1 MnO4 has a charge of minus, twice it will have -2. Then 1 SO3 has a charge of -2, 5 moles would be -10. 1 H has a charge of +1, so 6 times it will be +6. Add up. -2, -3, sorry, -2, -1, -3 and +6. -2 and -10, -12 and +6 would be -6 on the left. अब देखो यहाँ पर 2 into +2 +4, 5 into -2 -10 and 3 into 0 would be 0. So +4 minus 10 minus 6 is equal to the charge on the left. If the charges are balanced or equal on both sides, then only your redox reaction would be said to be balanced. मतलब बैलेंसिंग में वेरिफिकेशन मेथड सिंपल है, लास्ट में अगर आपके चार्जेस बैलेंस्ड हैं मतलब करेक्ट है, नहीं है मतलब कुछ तो गड़बड़ किया है। सो रेडॉक्स में आप लास्ट तक आने के बाद वेरीफाई कर सकते हो वेदर इट इज करेक्ट बैलेंस्ड रिएक्शन और नॉट। एटम्स बैलेंस हो सकते हैं बट इफ द चार्ज इज नॉट बैलेंस्ड इट विल बी रॉन्ग। इसीलिए टू वे वेरिफिकेशन है, एटम्स एज वेल एज चार्जेस। हेंस फाइनली वी से therefore the reaction is balanced. This statement is to be written in terms of atoms as well as charges, both atoms as well as charges. So this is the main application of redox.